Hello friends, today we will have a discussion regarding the basics of production. As all of you know, in the engineering stream, we have one engineering stream that is mechanical engineering. Along with that, most of the people consider that mechanical engineering and production engineering are one and the same. But that is not the correct concept. So regarding this, we are going to discuss about what is the meaning of production or production engineering. To start with, we have a basics of production. In the basics of production, we are having production engineering. Production engineering is a branch of engineering that deals with the design, planning, control and improvement of the manufacturing processes to produce the goods efficiently, economically and with high quality. So the objectives of the every industry is to increase the productivity and the efficiency. Apart from that, it is a reducing manufacturing cost, also give the emphasis on the product quality and optimum utilization of the resources. So production engineering covers the following things, that is production design and development, process engineering, production planning and control, quality control, maintenance, materials management and industrial engineering activities. All these will come under the roof of production engineering. Today we will have a short difference between what is manufacturing and what is production. Manufacturing is nothing but the conversion of raw materials into the finished products. That is called as manufacturing. But what is the production? So production is nothing but the creation of goods or services to satisfy human needs. So the conversion and the creation, these are the two important points to be considered while comparing the manufacturing and production. In manufacturing, there is a conversion of raw material into finished products, but in case of production, we have to create the goods or services to satisfy the human needs. So what is the input required for the manufacturing? That is raw material, machine and labor. These are the inputs which are required for manufacturing. But in case of production, the input criteria are resources, labor, capital and technology. See, manufacturing is nothing but conversion of raw material into finished products. And for that, you need only raw material, machine and labor. But in case of the production, apart from this, you need capital also, technology also. So, in case of manufacturing, we add the value in terms of physical transformation. That is, from a particular product or particular raw material, you give some shape so that you can add the value to it. But in case of production, you have value addition as creation of utility. So most importantly, you can see that all manufacturing is production, but all production is not manufacturing. This is, one has to understand that every production is not manufacturing, but every manufacturing is a production. So there are different branches of production engineering, which includes production planning and control. In short, it is called as PPC. So what does it covers? It covers routing procedure, scheduling, dispatching and follow. So routing means you have to make a proper route of the material or the product flow. Then you have to schedule how to route this. And also you have to have dispatching idea, how to dispatch, where to dispatch and where to stock the products and how to dispatch it, and most importantly you have to take the follow-up of all the things. This is the role of production planning and control engineer. Industrial engineering, one of the finest branch of engineering which deals with work study, time study, method study and product improvement. So one more thing I will add over here is the work measurement. So work study, time study and method study, these are the important parameters for any manufacturing industry. So quality engineers, they will do work as the inspection, statistical quality control, and total quality management. Maintenance engineers will do preventive, predictive, and breakdown maintenance. So material management plays the important role for controlling the inventory, then make the purchase of the material and also to store the material. So operation managements or the operation engineer has to work on the things like resource allocation, proper resource allocation, proper planning, that is capacity planning, and production scheduling. So once again I am giving emphasis on the industrial engineering, such as it concerns with design, improvement and installation of the integrated systems, which involves people, material, equipment, information and energy. So broadly the areas of industrial engineering, as we have discussed earlier, as work study, which includes method study, time study, then ergonomic considerations, that is human machine interaction and the workplace design, and operation research, in which we will have the optimization techniques and decision making models. Again, we are having quality engineering as a process control, quality improvement. Again, we have PPC and supply chain engineering, which is now emerging, that is logistic and inventory management. So shortly we will discuss about the work study and method study, that is the overview. As so work study is defined as, according to ILO, that is International Labour Organization, work study is the systematic examination of methods of carrying out activities to improve the effective use of resources and state standards of performance. So work study always does the systematic examination of the methods, that is the methods which are carrying different activities, which are to be used to improve the effective resources and set standards of performance. That is, resource allocation and resource utilization are the most important parameters where to use the proper resources. And method study is nothing but the systematic recording and critical examination of existing and proposed methods of doing work to develop easier, safer and more effective methods. That is, the methods which are already being done in the industry, you can have to have record those methods, critical exam, and also you have flexibility to propose the methods which will be easier, safer and more effective methods. So how to do method study? So this is the way you have to do method study, which is called as SREDIM, which stands for, S stands for select the work to be studied. What work you are going to do, you have to select it first and then record all the relevant facts regarding that particular work which you have taken into consideration. Then examine the facts. Whatever the facts you have recorded, you have to examine the facts very critically. Once you do all these things, then you have that to develop a method which you called as the improved method. Again, you have to compare that method with the previous method, so that any lacuna, again you can have that particular changes you have to make, so that you can develop a very improved method. Once you have developed that method, then you have to install the method and then again maintain the new method which you have already developed. So in conclusion, we can say work study is nothing but the productivity improvement technique. That is, it consists of method study and work measurement. So work study has two branches. One is method study and work measurement. And method study focuses on finding the very best way to perform a job. That means method study deals with the best way of performing the job, while work measurement to determine the standard time required to complete that job. Both are essential tools of industrial engineering for improving productivity and efficiency. Now we'll discuss about next part is the forecasting. Forecasting is nothing but the prediction. So prediction regarding the what is the demand, what will be the sales, what will be the production, what will be the conditions. So these all will come under the roof of forecasting. So why to do forecasting? Once you do the forecasting, you should go for the planning regarding what you have forecasted. then how much inventory you are having, if you have excess inventory or less inventory, or what inventory control you need to do, then what is your capacity, whether you can fulfill the particular demand, whether you have that resources to fulfill the demand, whether you have that particular budget to fulfill the demand. All you have to do in this particular capacity planning and budget preparation. Based around the time horizon, the forecasting are classified as short-term forecasting, medium-term forecasting and long-term forecasting. So short-term forecasting, it will be up to 1 year, so that you will have inventory and workforce planning in this particular short-term forecasting method. Medium-term forecasting will range from 1 to 3 years, where you can do production and capacity planning. While in case of long-term forecasting, which is more than 3 years, you can go for the strategic planning, so that in this way, based on the time horizon, the forecastings are classified. And on the basis of method, you will have qualitative and quantitative forecasting. Qualitative forecasting includes what expert opinion, Delphi methods, market surveys. While in case of quantitative, where you need to find out the quantity, you have different methodologies such as time series analysis, moving average, exponential smoothing and regression analysis. So these are the different methods which you can use for the forecasting purpose. Coming to the aggregate planning. So aggregate planning is nothing but there is a determination of demand and production. So aggregate planning is the process of determining production levels, what is the workforce requirement, what are your inventory levels, and what are the other resources, and it is a kind of medium term planning which ranges from 3 to 18 months. So the objectives of aggregate planning is to meet the customer demand, minimize the production cost, optimal utilization of the resources, and to reduce the inventory costs. So there are different strategies for aggregate planning. First is the level strategy, in which there is no change in the production rate and the workforce is stable. So there is no hire and fire method in this case. There is a constant production rate and a stable workforce, but inventory absorb demand fluctuations are there in case of level strategies. Chase strategy is exactly opposite of that. It has to be adjusted according to production rate, according to demand. So according to demand, you can change the production rate, you can vary the workforce, so you can hire the workforce if the demand is more. In some cases, you have to have new machines to be installed. So all these you have to do to meet the demands, and this is a kind of hire and fire method. So third one is the hybrid strategy, which are commonly used in the industries, that it is the combination of both level and chase strategy. One more point or one more aspect is the lean manufacturing, which is regarding the systematic approach for eliminating waste and maximizing the value to the customer with minimum resources. The major objective of the lean manufacturing is to reduce the waste and to improve the quality, increase the productivity and lower production costs. So the principles of this lean manufacturing include: identify first the value. That means you have to understand the customer requirement, what the customer needs. Then you have to map the value stream. That is, the identify what are the value added and non-value added activities. To remove as much as possible non-value added activities. Then you create a flow, that is the smooth movement of the materials and the information. Then use the pull system, that means produce only when it is required. Don't produce more than what is required, and go for the perfection, that is continuous improvement such as a Kaizen. So in lean manufacturing you will find 7 types of waste, which is called as MUDA. That is, one is overproduction. Don't go for the overproduction. There should not be any waiting time. You have to reduce the transportation cost as much as possible. There should not be any overprocessing. There should not be any excess inventory. There should not be any motion defects. and there should not be any underutilization of the human talent. You have to put the person right place, right time, right work, so that you will have proper production process. So overproduction, waiting, transportation, overprocessing, excess inventory, motion defects, and underutilization of human talent. These are the types of the waste you have to look into very much carefully. So lean manufacturing tools includes 5S system that all knows. S stands for the sort, set in order, shine, standardize and sustain. And more tools are Kaizen, which give emphasis on the continuous improvement, Kanban system, just in time system, Okayuk system, which is nothing but the mistake proofing, value stream mapping, total productive maintenance. Also you have single minute exchange of die. That means if you take an example, a press machine setup time when you reduce from 60 to 10 minutes through quick change tooling. Pokayuk means mistake proofing. That means you have to design a fixture so that you can have that component to be assembled only in one correct orientation. Value stream mapping means entire production process and excessive waiting time should be less. Cellular manufacturing, machines required for producing a particular component family are arranged in a particular cell. And the Kaizen is nothing but the continuous improvement. So at a glance, if you can say, so if you are going for the automobile, you can employ just-in-time Kanban and TPM process. For electronics, you will have cellular manufacturing or Pokayuki system. Aerospace, you can have value stream mapping and Kaizen. Healthcare, you should go for the reduced patient waiting time. Food processing requires no doubt just-in-time inventory and waste reduction process. So friends, we have discussed in short about the production engineering and its scope. So hope I have cleared some doubts of yours. So in the next lecture, we'll discuss more about different aspects of production engineering. Thank you very much.